Welcome, everybody, to our first MIM Tech Talk of spring 2021. And we're very happy and delighted to have Jeffrey Malafsky come to talk to us about the nature and impact of hidden data errors on information risk and data science. Jeff has a PhD in chemistry from Penn State University and was a research scientist studying fundamental nanotechnology at the Naval Research Lab in Washington, D.C. Subsequently joined SAIC and was Director of Technology Innovation, supporting diverse clients in DARPA, ONR, and DoD as a technology expert on advanced programs. Jeff formed his first company, TechI2, providing technical expertise to large government and corporate clients in data integration, metadata implementation, semantic technology, enterprise architecture, and knowledge management. And some of the lessons that he learned from this work led him to form his second company, which is where I met Jeff, a company called Phasics Systems, when he was promoting that company, which developed a custom enterprise-grade product called DataStar that blended critical components of the disciplines into an integrated framework working on top of Hadoop for big data normalization and custom business logic for high performance computing. He's now the CEO and chief scientist of two different startup companies, Technique Interlytics, and I'm sure you're going to correct me if I pronounce it incorrectly, and Safe Haven. Technique Interlytics refines the technology and methods established with the enterprise data normalization product into an automated data expert system that performs deep inspection of diverse data sets to discover and correct in real time complicated hidden data disparities to prevent high quality data science processing. His other company, Safe Haven, provides B2B API based identity management and consolidated parental controls for youth, esports, and online gaming with strong security, ease of use, and adherence to industry standards and government regulations. Today, Jeff is going to talk about how his company's technology addresses information risk, and I'm going to hand it off to Jeff, and I'm going to turn I'm going to stop my video and go mute. So, Jeff, thank you very much for coming to talk with us today.
All right, well, thank you very much, Dave, and it's a pleasure to be here. And I will continue to monitor the chat as well as Michelle and David. So if anything comes up, just send me a quick chat via this video. And so as Dave said, the conversation I want to have with you today is about hidden data errors on information risk and data science. And so the first place is to talk about the topic matter and why I'm bringing the two of them together. As Dave mentioned about my background, you should see that I'm most interested in what is effectively a quality, correctness, and proactive capability to achieving success, wherever that success is. The information risk area is actually a very interesting area, and because it is inherently interdisciplinary, and as you can see from the current slide, it crosses some boundaries that are normally very separated in organizations. And it's also very interesting because as we go further in the world and we make use of these data technologies, and we also are concerned about the use of data. So that's the growing concern about privacy. So there's a law issue, but it's also the old view that would happen in organizations that you can have reputational loss, you can have efficiency losses. There's lots of areas around that. So I'm going to make the case that information risk is a high level field and that it's critically important and becoming ever more important as we go forward. So for those of you who are entering this field in the master's program, it would be establishing you as one of the most important people, in my view, in the environment. Now, that doesn't mean that it's going to be super easy as you get there, and we'll talk about some of those hurdles because they actually increase risk. And that's one of the nice things about the field of information risk is that the risk component of it brings in lots of different parts. The data science is similarly interdisciplinary, and you can see all the different things that it includes. It's not just going out and doing some machine learning. If it was just doing machine learning, it would not be data science, it would just be machine learning. And the same thing with any other component that you bring into it, whether it's statistics or analytics or integration. All of these subfields have existed for a very long time, and they've been pursued for a very long time by a lot of smart people, creating a lot of good products, and their organizations have created management staff to sit on top of them. and all this. So we're going to have to see, why is data science something new and what's special about it? And the key word there is the first one, interdisciplinary. Then we're going to talk about how data has a central role in risk. That should not be surprising, but it's more than just data. So some people come out of large organizations and things get so siloed in that large organization that it's commonplace to think of data as being managed by the CIO office, or maybe by a business unit like the CFO, and they're taking control of it to do something. But in risk, there are things called compute risk models, and that it would be interesting to have a whole talk just to pay in the nature of the risk models. And that's actually very interesting because that brings in actual real math, and it brings in real knowledge. And so I worked with one company where they were doing risk for underwriting international trade, and minor variations in the source data could make or break that underwriting capability. So we have to think about it that way. And then the next part is that data is really multi-purpose and context sensitive. And so I really want to get that point across heavily. We talk a lot about data, but if you separate data from its context and the intrinsic knowledge by which you use data and you judge the data, then it's just sitting there. It's just sitting there on a table, it's just sitting in a database, and it's really not of much use. So we want to talk about that. And then finally, we're going to talk about some scenarios or real world situations that should put all this all in context for you, and then what our next step is, what we're actually doing about it. So these two show about the quality data, and then quality data is actually critical for both of these. So on the left, you see the data lifecycle, data science lifecycle. And what I want to point, and that comes from Microsoft. So these are both of these graphs come from esteemed organizations who really have spent the time and money to build up the staff who are knowledgeable and experts in the field. And then they're bringing this back out to the world for use. So one of the things that should really take your notice right away is that both of them are obviously not simple linear progressions. It's not a simple linear workflow where you start on the left, even though it says start up there, and then boom, 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 you go through a couple steps and you're down at the bottom. Notice that it's more of a web, that the actions, the people, and the data is going back and forth all the time. And that's an important concern here. And what it means is that the stakes are actually increased on how you view data, how you have to manage the data, and importantly, from a risk point of view, now think of the risk of something being slightly off. So if something is slightly off in either one of those diagrams, notice all the touch points that it has. Information risk is the likelihood of occurrence of something happening due to influences, and then that generates some impacts. There's many types of risks, financial, reputational, security, and program. Information is a primary influence to almost everything that occurs. So if you're a compliance officer, and nowadays it's more frequent to actually have a chief compliance officer, then you depend upon the information flowing up to you. How could you be a chief compliance officer and be doing the best you possibly can and still fail? So ask yourself that question. That's the risk component of that. And the answer is you get incorrect information, you get incomplete information, or you get information in a non-timely manner so it doesn't fit in with when you have to do a report. Similarly, for planning and decision making, audits should be obvious. You have audits for accounting, that's obvious. But in the work that I did that Dave talked about, I was also the lead to do the security audit because I built the data normalization system. And so it was touching a lot of secure data. And so you had external auditors coming around to do the accounting, did the accounting pass audit, but also for the security of the system itself and the security of the data itself. And some of those audit issues that show up, even though it's a security concern, yes, you worry about privacy and encryption, but it is, one of the things I found very interesting that was very excellent was that the security frameworks also cared about was the data in context? And normally you might say, well, now why is the security person concerned about that? Because keeping something secure depends upon whether you can weave pieces of information together so that some evildoer might get intelligence out of that. And that's an age-old intelligence question, is a multiple separated pieces of data by a knowledgeable person who has initiative and intent can be woven together to give them actionable intelligence. And so we're really in that world now. So when we talk about information risk and we talk about data science, we're really now stepping into that world. Information is combine unstructured descriptions with the structured data. And so we want to do that, but again, it's not additive. So you hear a lot about, like, particularly in big data applications, oh, we could have the unstructured data and the structured data co-hosted in our data lake or in some other big data forum. Okay, great, it's there. That is a good thing. So from a management point of view, it is good to have it there, but what are you going to do with it? And that's the world that I lived in for a long time, is how do you actually take something from the unstructured data, marry it up with something from the structured data. You're not quite sure if either one is absolutely correct. You then put them together and you go off and try to do something with that. That's a good thing if you can go do that, but now you have raised your risk level. Your risk exposure has gone up simply because you've done that. A couple of quotes that might hopefully bring this to bear. I always like these. One, the top one has to do with the shuttle explosion, and the bottom one has to do with the financial crisis in 2008. The first one is, I'll let you read that. That comes from the standard NASA report, but I colored in blue really what you should be taking away from here, which is that the management of NASA, and the first thing here is to recognize all these people are well educated, they're high quality professionals, they're sincere, they want to do a good job, they actually care, but this is the fallback. This is where the risk showed up, is they believed it to be true. And what did they believe to be true? They believed that they could skirt the engineering limits, what's called the boundary conditions of the various components. And with the Challenger, it was that Florida had an unusual freezing spell, so there was actually ice on the outside of the Challenger pre-launch. And that was outside the boundary conditions of what was considered, from an engineering point of view, safe. That quote in blue is saying the managers decided, because of the value to the organization of going ahead, that it would be okay. They essentially convinced themselves that it was okay. And what Richard Feynman is saying here is that it was an incredible lack of communication between themselves and their working engineers. Well, you might say, okay, well, why don't they get a better system and communicate and do all that? That's not the problem. That's not the source of the risk. The source of the risk is human nature. People can hear the words, they can sit at the table and say the same things to each other, but that doesn't mean that they're really listening and hearing and understanding and willing to take that action. So as an information risk professional, that's where you need to step in. That's the place that is the catalytic effect that you can have on an organization. Similar thing happened down at the bottom one, and this is a review about Lehman Brothers destruction. And again, it was pretty much the same thing. Lehman Brothers had the staff, they had the management, they had the experts, they had high quality people, but they created a culture where they decided that the reward of going out and trying to make money off of these components was better than the risk. And there were people, I guarantee you, there were people inside the corporation saying, this is too risky, this violates this risk exposure equation. And it's the human nature component. So then you say, who's going to be the one to prevent these things in the future? Human nature being what it is, we will educate, you will put in frameworks so that the managers and the engineers and the business analysts are more aware, but there still needs to be a gatekeeper. And that's going to be the information risk professional. And what we just described was the well-known issue of risk from procedural bias. And this is actually a major danger point, and I did a lot of work in the federal government, in the Department of Defense, and for large corporations. And what is extremely common, to the point where you can count on it happening every single project, is that you have a lot of high quality people assigned to different teams with different roles and responsibilities. And obviously everyone's focused on their role and responsibility and their team. And then what happens is, because it's a big organization with a lot of activity, is that we rely on these frameworks, like the risk management framework. In the cybersecurity world, you have the STIGs. There's others like the ISO risk management framework. And that's a great thing. Those are really great. The problem is they generate risk on themselves. If you put too much reliance on going through them and simply saying, hey, we filled out the form, we've done this, we've done this, we've done this, we have now reduced our risk, you have not, in fact, reduced your risk greatly. You have reduced your risk somewhat, because those failure modes that we talked about just a moment earlier did not come about because people have forgotten to do the checklist. They had done their checklist. It comes into the human decision making, the managerial side. What are people willing to do as a trade-off decision? And that's where you need these gatekeepers. And these gatekeepers go by names of information risk professionals, but also red team reviews. That's another common way. And then we get into this, what you need here, as I show at the next to last bullet, is I put in caps, for those to work, for these gatekeepers to work. And I have been this person on a technical, I have participated in teams where it was this external review team, and I was the technical lead on that. The review team has an all-stop possibility. What does that mean? If we issued a critical finding, the project stopped, just stopped in its tracks, and nobody got to question that. Now, you don't do that and walk away. You do that and work with the project to come up with a corrective action plan, point out what the risks are, point out what the errors are, and the objective is to get the team to understand where they may have let down their guard a little bit and how to overcome it. But human nature being what it is, I can pretty much guarantee you that in any large organization, the meeting, the project team is going to have a checklist mentality. So somebody, the risk professional, needs to be there constantly nudging against that. And this is the various ways that data plays in the information risk area. We talked about these, but notice that it can be various places such as even efficiency of operations. I've been in many, many programs in the IT side, the data management side, even higher level in the data science side, where in some systemic errors in the source data files literally have consumed months of meetings, of finger pointings, of organizational friction. And it took an expert, which in those situations happened to be me, to find out what the root cause was and then fix it. The reason it took months is that frequently organizations don't want to bring in the outside expert until they have exhausted all that time doing the obvious stuff and finding that it didn't work. So instead of months, the fix could have happened in a matter of a few days, because I found it very quickly. And so that's kind of the point. From a risk point of view, can't you somehow convince them to bring in outside expertise sooner? So someone just asked, well, doesn't say what you're saying, something like the risk management framework actually requires its own risk management activity? And I would say yes. I would say that that is an innate function of the risk professional. Don't just take the RMF or any other framework and think that you go and do it. I take it and I do it. You have to understand it. You have to understand how you get the information. You have to also understand how people might be hiding that information from you. And then you say, well, nobody would ever do that. And my counter to that is that has also happened in every single project I've been in. I've had information hidden. So part of my job as the expert was understanding how computers work. I do. I'm an expert in computers. I know how they work. So I've actually literally had meetings where people have told me that they're doing some sort of real-time streaming application and there was a breach of data, but the data doesn't exist. It's never there. And the point is, if you know how computers work, the data is there. It has to be in the CPU, it has to be in RAM, it is there at some moment in time. Just because they think it's not there because they're not storing it persistently in a database is not the same thing as the data is not there. And hackers are smart. They can reach into RAM, they can reach into the CPU. So the point is that I knew that. I essentially educated them on how computers work, and lo and behold, we got the architecture diagram, we found out exactly where it was, we found out what the problem was, and we fixed it. So as a risk professional, you need to have some understanding of what's going on that led to the RMF and led to those frameworks. Data science, similarly, is the science part of this introduces the notion of having verifiable conclusions, and that you're using techniques, and the techniques that you choose are the ones that help you solve the problem. It's the ones that make sense. It's not a prescription to always go do the same thing. It is what makes sense. And you notice what's at the end there is knowledge management, and then that is a critical part of this. So when you're in data science and you're doing information risk, the knowledge component is critical. It relies on awareness. You have to understand the scope and accuracy. That's what I was just responding to with the question. You as a risk professional need to really comprehend the scope, when things can be used, when things should not be used, when data is in context and it makes sense for this use case, when it is out of context and it does not make sense. And that is something you have to comprehend if you're going to truly get a handle on the risk. And so I'm not going to answer the question, but I have one there for you. So there's a lot of these topics that are floating around. So the question is, how do data analytics, business intelligence, and data science differ? What is the difference in them? A lot of times they're thrown around and you see the same thing. If you go to a data analytics page or a business intelligence review or data science, they're showing you the same cool three-dimensional graphs. They're telling you to go write some Python. It all looks the same, so what's the difference? One issue is that data science uses advanced technology, and this is very important. Data science is not itself advanced technology. Science is not technology. Science is the procedures and the culture and the approach to doing repeatable, verifiable experiments and getting the knowledge from that. We use advanced technology, but data science is not a technology field per se. And then how do we bring the science to data? So what I just said, systematic methods, validate, question assumptions all the time. That is another component of information risk. And then you have to make sense of the data. And that is very, very true of the risk component. You have to really have a sense of what is the risk, why is it arising, how can it be abated? And if somebody tells you in a large program, which you will most likely be in, that we got it covered because we did the whole checklist and we're guaranteeing that we did the checklist and it's all good. I cannot tell you how many times I've heard that to then prove that no, they did not do it because they overlooked something. That overlooking of something is what is going to be the most common cause of risk emanating upward and throughout the organization. So, and one way around that, you won't get this to be instantiated in an organization in a large way, but another quote from Richard Feynman that I really have always taken to heart is that, I'll just take you something there, is that you should report everything that you think might make it invalid, not only what you think is right about it. Again, that mentality of always looking past what seems to be the obvious, hey, we've done this and we're done, let's move on. No, have a little bit of, I want to look at that a little bit further. And then again, we'll show you an example from my own history. I was a research scientist in nanotechnology, doing fundamental and basic applied science. And this is the kind of stuff. So the fun part of science is getting cool data and making sense of it and coming up with a conclusion and writing a paper and going to a conference, giving a talk. I did a lot of drudge work before I got there. I had to check every single sensor on my equipment and I had to calibrate it. And I didn't just calibrate it once and leave it there. I had to calibrate it specifically before I ran experiments that I had planned to publish. I always had to check the question of what could possibly be wrong here that I'm not even suspecting, that I'm not even aware of. And I had to put that into my research paper. So when you publish to a peer-reviewed journal, it was my obligation not just to say, here's what I found and this is what it means, but this is the stuff that I've done to say that it's not something else. Here's the length, the level of effort I've gone through to say, no, this is, it might be that, but it's not because, or I don't think it is because of that. And then we get to the nature of data. So data is a thing. It just sits there. It's something. It has to have context, scope, accuracy, and pedigree to be useful. And then this actually comes out from examples from some old knowledge management stuff I did, is take a simple data record that you see there, state, zip code, city, lat, long, and you give one there. And I purposefully modified my latitude. I transcribed a couple of digits there because that happens all the time. So the point is that this sits in a database and this gets rolled up into reports or on a dashboard, or it gets sent in as part of the RMF audit, then somebody needs to question whether it's correct. The question is, who is questioning that? Well, I can tell you from an extensive experience, nobody in the data management groups is doing it. Nobody in the CIO office is doing it. None of the DBAs are doing it. None of the data engineers are doing it. None of the data wranglers, and I'm going to admit I really detest the term wrangling because I don't really know what it means. And then none of those people are doing it. None of those people are questioning, is that value sitting in that column, in that record, in a file or a database, is that the value that it should be? And then it goes downstream, and there's this assumption that when data comes from the data management infrastructure, that it has been made good. And that is a wrong assumption. So that is a critical point of risk right there. So now we get to the hidden data. And then I'm going to spend some time on these scenarios. So the idea is that this 80-20 rule, which is a broad statement of a Pareto distribution, we're going to use it in the context that a lot of people do, that 80% of the data errors are really easy and they're handled. There is a large number of excellent modern tools out there to do data quality, data integration, and data prep. And even though I'm not a fan of the term wrangle, those type of things are doing a good job. And so all the cloud purveyors have them and they do a good job. But if you really look and see what they're finding the 80% easy stuff. They're finding that some of the numeric values are out of range, that some of the strings that are inside of an address field are kind of funky, or they're not the same name, they're not the same city, or that they're concatenated and you need to splice them by comma. All that kind of stuff is pretty standard and run-of-the-mill nowadays. And then that could be, you can even do that in Python, you can write your own scripts to do that. So that's great. I'm not worried about that stuff. I'm talking about the next level. I'm talking about the 20% that are more complicated, and most of the time, people are not even aware that those other 20% exist. And that's a huge risk. That is the area that I primarily worked in, not because I wanted to, but because it came up, and as an expert, I dived in and I figured them out. I never found the data set where I did not find the root cause and then I could not fix the root cause at the data level. So what did we do this? And we do this from deep inspection. And now I want to talk to you about some of the outcomes of the risk. And this is where you might actually get brought into a program. It would be great if the risk professionals were brought in at the start of the program, but likely not happening. Likely you'll come in when the program is already having some problems, and then you're going to have to quickly discern what's going on. One of the things that'll happen is that there'll be a great deal of organizational friction. Human nature, people will stop cooperating. They'll show up at the meeting, but they'll actually start pointing fingers. They won't be sharing information. Now, the good news is, as the risk professional, if you're using one of those risk frameworks, they will be required to give you anything you ask for. So you need to know what you want to ask for. You already need to know when you go in there what it is you're looking for. Can these problems be solved? Absolutely. Can they be solved with the existing policy, schedule, staff, and tools? About halfway. And then we'll talk about that. So now we're going to go through some real world examples. And then these are actual things that happen. These were ones that took weeks or months to solve, and the weeks or months to solve were because the people tried to use their existing staff, their existing procedures and tools, and they went around and around and around, finger pointing, thinking that the network ate it. There was always some variation of the virtual dog ate my data. It was, you could distill it down to that. And it was not that, it was never that. So the first one I'm going to show you is when Chinese characters show up in Microsoft Excel, and when you import them from a database extract, that's really mind-boggling if you've never seen that before. And then on each of these, I'm telling you how long it takes, the staff that was required, the risk level, and whether it could actually be solved with standard tools and procedures. And you'll notice that under staff of each one of these, at the end is an expert. And that is something I need to get across as early as possible, that if you're going to be in the risk game and you want to help solve some of the problems, reduce the risk for your organization, it's unlikely going to occur by just viewing the existing system. And that's not a negative on any of the people. The people are capable, they're educated, they're intelligent, they're highly motivated, they have initiative, but you have to remember what happens when people get assigned to teams and groups. There's an organizational component of this that disallows rapid solution. So part of the value is the same reason that red teams come in from the outside world, is that you need that external view. You need that external person who's not participating in the internal organizational structure. So the first one, and I'll lay it out as a scenario, and you'll see the picture there, that's actually what it looks like. So a business analyst opened up Excel, now they imported the database extract, and that's what they see. And so now you say, okay, well, something's wrong. Well, the problem is that this is a very large organization, and it had a large program with strict governance controls. They already had auditors. They were already using the RMF and the STIG. They were already doing all this stuff. It was a big program team, hundreds of people. There were formerly people in charge of doing the risk audits. Nevertheless, this is what happens. So the presumption was the file was corrupted, so the natural is, let's go back. Let's go back and tell the database owner, hey, somehow the file's corrupted, give you a new one. So you do that, they go and check their database, the data's just fine. They create another extract, that's just fine. They send it over the secure network, you get it, you repeat it, hey, same problem. So you go around and around and around on that. Then everybody has an idea of what could possibly be wrong. Boom, 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 you go around. Now management gets involved and they say, we got to solve this today. Well, today does not happen. But what it does happen is that the data engineers, now your high-priced staff, get involved. So the clock is ticking. And they're asking you the hard question, what's going on, where's it going? And they can't find anything. You get network engineers involved. The bottom line is the project's at an impasse. Why is the project at an impasse? Because you have to meet accounting audit requirements. This data is required to come up with the aggregated accounting numbers, so you can't go any further. So what was the root cause? So what came in, again, I was this expert, is that you stop expecting anything to be correct. You go back to basics and you just say, what could possibly be wrong here? What could possibly be going on? And so I'm exploring possibilities. I'm looking into things. And so one is I looked at the file at the operating system level, and I had to do it at the binary level, I had to do it at the file level, I had to use a bunch of different tools. And this particular one occurred because there was something called a byte order mark, which is what determines the encoding of a file. And it was an orphan version because this file had been moved across so many computer systems with so many different operating system encoding levels, and included the Hadoop HDFSS, that it got orphaned, as simple as that. So I had a specialized tool where I simply modified that byte order mark, and lo and behold, the file was now useful. I then automated that process so that all the files coming in. And the risk for that was that it would fail all those things. The next one is that governments requires the aggregation prior to the pipeline run, and we have another Excel one. So the good news was this structured organization had a QA process whereby the business analyst would always take a sampling of the data. they bring it into Excel, they make pivot tables, and they'd actually do aggregated sums to see if it passed audit for that subset of data. And it was almost CSV, always CSV, because people love CSV. And then what happened is they would then go to production on it, put it in the pipelines, and then put that into a dashboard. And now everybody can see the dashboard, and the aggregation sums were wrong. Again, you go through all these things, you do the system tests, and it all looks fine. More weeks, more data engineering, more management. And then, so again, it was me, it happens to be. And so I go and I explore. And what I explore is I look at the Excel, I then looked at the CSV, and here's the point. Nobody ever looked at the CSV files that were exported from Excel, because the assumption was Excel makes CSV files so often, why would I bother? And here's what it is. Excel has a built-in decision-making apparatus whereby it will take long numbers, or what it thinks are numbers, and put them into exponential format. And that's what you're seeing. That's actually a very long accounting code. So it's not that, but it turned it into that exponential. And then you might obviously think, well, it did that just for the display. Under the covers, when I export it, it's going to go back to the number I entered. That's what it was. And the answer is no. When you export it, Excel actually exports it in exponential format. So now everything downstream is going to go wrong. If you import it, it's not the same number, it's not a code. A lot of parsers will crash on exponential format because it sees the E+, and now that's a big problem. Again, once I found that, it was relatively simple. Now people know how to do this manually, and it's painful. In Excel, you can manually convert a column to string format, not general, but you have to do that before you import the data. If you do it after you import the data, you could still end up with the exponential. So it's a very painful process to go through. So again, I created a custom app, I put it in the QA cycle, problem solved. These are a little bit more complicated. And so this happened after the wrangling, after the integration, and there were severe aggregation errors in dashboard. There's nothing like doing aggregations over large data sets. And here, by the way, we're talking hundreds of millions of records. So these are very, very large files. You cannot bring them down to your desktop and open them up and look at that. You need specialized tools. They're going to be stored in a big data storage area. It's not easy to get to them, and to do that, the source owners all had documentation saying that the data passed their own QA checks. So, but again, a lot of time, and this went on for a very long time. And so up at the top, you're seeing some real data. It happens to be IRS census migration data. And what you're seeing are some of the core problems that occur there, which is what other two are, is their parsing errors. So it shows up that the fields are shifted relative to the fields in the columns, and you'll see things like text inside of a numeric column, or down at the bottom, the other one is, you'll see that even though there's supposed to be 8 elements in each record, there's only 4 sometimes. And where does this arise? So you have to go through. Now remember, this is buried inside of hundreds of millions of records. So you can't get there. And what does that mean? No, your wrangling tool cannot read these files. All these great tools, and they are great, are limited in how much data they can read. So they can say that they read it in, but what they try to do in order to give you those very cool graphs that you can interact with and do interactive wrangling is they're keeping the data in memory. Can't keep several hundred records in memory. Just not going to do that. So it doesn't work. So you're not getting there with the standard tool set. So what we did was we did it in a specialized tool set, and then the resolution was twofold. You could request new extracts, which people tried, but it still had the same problem. So now we had to go through another round of saying what's going on there. And what's happening is, if you look at the top one, it's due to this issue that databases in text fields very commonly have embedded delimiters. So people are using commas. That means there's a comma in the field. And they're line feeds, which are invisible to you. So they're invisible to the database engineer. That's why the database engineer will say it looks okay. I have actually seen records which had over 100 line feeds in a single record. And what that means is when the extract is made, instead of having the record on one line, so it gets read in by Excel or read in by your pipeline parser as a single record, it actually looks like 100 records, 100 distinct records. So what we did was we built in a custom algorithm to automatically correct that. We gave it the cool name AutoStitch. And the last scenario I'm going to talk about is that when the pipelines themselves crash. This is your sexy big data tool, just crashed, they stop, massive error numbers, but it looked okay in Excel. This one is due to invisible characters. This is also very common when you go through different character sets and databases. It's also very common if you work in an organization that has an international footprint, because you might have some French characters that are being used or some other language characters. And what I'm showing you, or visibly in the second picture there, is you see those odd characters at the end. I did that just so you could see it. But up above that is with a custom app is detecting the existing of that. And then what happened? So we fixed that. So again, we went through the same thing here of discussing it, of discovering it. We fixed it, and then we brought it back out. But this one is particularly befuddling to people because these characters are often invisible. And so then you won't see them. So then the last couple of slides are simply, how can we reduce the data risk? One, expect the unusual. Be looking for it, and be looking for it as evidence in these various places. Two, I make the strong case, hopefully, have an external expert ready to go. Be prepared to bring an external expert, and then do deep QA all the time. And then the mindset should be a total quality mindset, not a checklist one. And then to summarize, I won't read this to you, is what we're talking about. That your data very likely does contain errors, regardless of the coolest tools, the checklist, the big data, the cloud, the errors are there. I've never been in a large organization where I have not seen these errors that I've described be there, which is why I wanted to point them out to you, and that expertise is required. And then finally, what we are doing about it. So I'm going to be, this is the kind of the kickoff. I'm going to be creating a series of web seminars on practical methods and lessons learned on this area, hopefully to help people make use of that. We're targeting at the end of February of this year. You're free to contact me at this email. And we are also doing a lot of public speaking to try to get this information out there. UMaryland is one, also with my friends at the Bloor Group. And then finally, what we have done is distill all these lessons learned in those custom applications and algorithms. And we've actually built a self-service automated expert system as a data science prep tool that we're also bringing out, and it should be unveiled in a couple of weeks. And the goal of that is so that everybody can get the benefit of this and not have to write these extensive JSON config files or do data integration and do all this stuff. But it's been bundled together, so it's a one button. Here you go. We'll find it and we'll fix it in real time and give it back to you. And there's a coupon code there if you so decide to go there that will give you an extended trial. So with that, I will stop.
Thanks, Jeff. That was actually quite comprehensive, and you brought back some painful memories of digging through reams of CSV files looking for those unprintable characters, which definitely, I agree with you. They show up those types of problems that you were talking about show up a lot. I actually have a question, but I'm going to also try to motivate those who are attending. If you've got some questions or comments, please go to the chat or unmute yourself and undo your video, and perhaps you can ask directly. I have a question, which is, you kind of started at a very high level. You talked about very high level aspects of information risk and the use of the risk management framework and inherent risks of using a risk management framework. But by the end of the talk, you really drilled down into you cross that boundary from information risk to data risk. And I kind of feel like that boundary is a little bit fuzzy and is also relatively important to differentiate between, ultimately what's the difference between data quality and data cleansing and overall information risk. So could you talk about where you see that boundary being and how you navigate the interactions or the correspondence between higher level information risks and lower level detailed tasks that you can perform to address data risks?
Sure. So the information, let's start with the information risk. So you have information risk of something. The information risk could be of not achieving the objectives of the large program accounting audit, not having accurate risk models like in the financial sector for the risk exposure of a financial institution, insurance like the one I worked with, of coming up with incorrect risk exposure calculations, which then means you create a certain product, which is the underwriting of that, but your risk exposure is much higher. When you get into the risk model component of any field of risk, these tend to be very sophisticated mathematical models, and they actually do bring in unstructured data and structured data. So for example, for that risk underwriting one I mentioned, the unstructured data was effectively reputational past performance of the partners involved there. So now, like any mathematical model, the error propagation, which I didn't want to go into here, which is a topic on its own, error propagation is, if you're familiar with the field, means you have some percentage of error on your feedstock, your source data, structured, unstructured, and also on your assumptions that go into your model. And then that can propagate rapidly depending upon your model because it gets used many times in the computation. So then you can start out with a 2% error rate on your input and end up with a 50-60% error rate on your output. 50 to 60% error rate in the risk world is a very, very bad thing. That means because bad stuff can happen, and even though you're doing the information risk management and analysis, it occurred. The bad stuff occurred on your watch. So it gets into where are you on that, and that's kind of why I kept drawing the line to don't go into checklist mode. So it's common to take a big framework like the RMF or the STIGs and just say, oh, it's so big, I just got to go through the checklist and do everything. But a lot of the risk is the glue that's in between those. And so if the risk professional, you have to ask yourself, well, you're sitting at the top of the pyramid, you're supposed to be the guardian and the validator of the risk exposure for the organization. So what happens if the people doing the database engineering and the data integration aren't paying attention? What if they're not catching these errors? So do a manufacturing line of automobiles as another example, the older American view where you did quality measurements of individual parts and then you assembled and went out the door, you got a kind of a lousy car. And then the Deming approach, the Japanese picked up on, which is the total system view. What is more important than the individual parts is how the total system comes together. And then you can reverse engineer if that subsystem doesn't come together, which would be the information risk, where it arose, and you go back to that. So it's that connectivity point there. And I'm making the case that the information risk professional needs to understand how the data is arising, being used, being massaging, and then flowing in, because ultimately it does get used in information risk.
Thanks. Also, again, if anybody has a question, please post it to the chat. But while we're waiting for our next question, I have another question, which is, if any of our students who are attending right now are interested in pursuing information risk management as a career, what kind of suggestions do you have about what the types of things that they should be looking at and the types of organizations they should be looking to join?
Well, so I think one, it's a great profession. I think that the program you laid out, I looked at it, is great. I think it's excellent. You really kind of cover the interdisciplinary side, and I think that you have courses that kind of go through that. I would say to folks, it's an exciting area, and it's going to become a good profession to be in because this risk issue is growing. And there might be a pull to it from the bigger headlines. The bigger headlines is the incessant occurrence of data breaches and what happens from that. But the other headlines are the kind of under the too big to fail. That problem is not going to go away. If you're going to go into the government area, it's the sorry story is most business IT data programs don't achieve their objectives. They just don't. And then it's all endemic in this. So you could be a superstar if you went and did that. And corporations, if you who care very much about getting it right and getting the risk exposure down, if you're the person who learns this material, this interdisciplinary material, and you truly, even if you didn't become an expert in this computer nature of it, but you simply had, every time you were going to work every day, you understood the scope issue. When is it appropriate to use? When is it inappropriate to use? You understood that scope. And let's say you took a review of some of the deeper issues, like what is a cybersecurity architecture? You should at least know what that means. What is a data pipeline? What does that look like? You don't have to spend a lot of time becoming an expert in that. You can actually just get a free cloud thing, and go through the tutorial on Azure, Amazon, or somebody else, and just see what it's about so you can have a comprehension. I think that it would give you great insight and make you one of the critically important components of an organization.
Thanks. Actually, for those of you who for whom your reference kind of flew by, you made a reference to that program, and the program I think you were specifically talking about was our newly approved certificate in information risk, privacy, and security, which is a 4-course certificate program, but it's also mimicked in MIM's focus area of information risk management. So those MIM students, if you're interested in this topic, we do have a focus area in information risk management. And for all of your friends who are not yet enrolled in a MIM program, let them know that we have both MIM and we have the CERPS, the Certificate in Information Risk, Privacy, and Security. So I'm going to thank Jeff. This has been a really great overview of this topic, and really appreciate your ability to walk through it so seamlessly. I want to thank you again for speaking at our Tech Talk. And so I'm going to stop the recording. Jeff, thank you very much, and appreciate your being able to visit with us. Thanks.